Yeah, welcome to today's class. Today we want to look at for loop variation. The last class we did for loop. So we are going to look at different variations of a for loop. Now you know that a loop basically has three component parts, which I told you in a while loop, which are what? Initialization. Then you have two, we have the condition, right? Then three, you have the update, which is what? Increment or decrement. Increment slash, or that is decrement, right? Then there is another part, which is what? The body of the loop, right? This one. Now, why am I writing this for? A loop is like setting a goal. So this one is the starting point, right? This is starting point. Then this is the goal, right? These updates are what? The steps that you are taking. Then this is what? The task that you perform to achieve your goal. So a loop is like a goal setting. Now, there are various variations that you can have for a loop, depending on this initialization, the condition, and this update. So we are going to write few programs to illustrate the variations that you can find in a loop. And then I will use that to explain how it can affect real life manifestation in terms of goal setting, right? So let's look at this. Now, I have something like this, int a, right? That is, I declare a variable in the integer realm. Then I say for inside this place, I say assign a to 0. Then I have this. This is very important. Then I have a less than or equals to 10, right? And then I do this again, and I put my a plus plus. Now this, then I do this. Then here I'll say print f, and then I'll say a. I will put my this, then n, a. So this is a statement, and then this, I'll close it. Now, this is the declaration of the variable in the integer realm, right? Now I'm assigning a value which is 0 to a, and this is my condition. So this is my initialization, the starting point, and my goal is to bring out all the values that are less than or equals to a. So starting from 0. So this will give me 0, 1. Okay, 0, 1, 2, 3, 4, up to what? 10. 0, 1, 2, 3, 4, up to 10. A is less than or equals to 10. So A is 0. That is true. It will come in and it will print out A. It will print out A. It will print out this. Then it will increment it by 1. That is the step that it's going to take. So I'm moving the step, one step at a time, until I get to what? Where A is less than or equals to 10. So when A now becomes 11, it's no longer true. It will come out of the loop. So that is how you set. That is one. Now, this, another condition is, another variation is that this is not always equals to be, not always going to be plus plus or minus minus. I can change this place. I can change this place. I can change this to, I can do this. I can change this to 2 and then do this. If I do that, maybe a less than 20, I can do this. Now, when I do this, what will be the output? What will be the output? So I am having my starting point as 0, and then I'm having my goal as counting up to 20. I can put this one back again as equals to a less than or equals to 20. But I will have my increment as 2. So what this is simply saying is a assign a plus 2. So a is 0. A is 0. I'm assigning initialization. The starting point is 0. A is less than or equals to 20. That is true. It will come in and it will increment a. It will print out a, which is what? 0 on the screen. Then it will increment a plus assign 2. What does this mean? It means this. So that will be a. A is what? 0. 0 plus 2. That is 2. That will now be a equals to 2. That is what this will be. Then it will come back here to check. A less than or equals to 20. That is true because 2 is less than or equals to 20. It will go in and it will print out a. So it will print out 0, a, 2, a, 4. Because in the increment, a is now 2. So what will happen will be a will be equals to 2 plus 2. That is 4. You reassign it to this. That will be 4. So you test. 4 is less than or equals to 20. That is true. It will come in and it will print out this. So it will print out 4. Then it will increment. So that will be 4 plus 2. So it will give you 0, 2, 4, 18. Up to what? 18. And then 18, then 20. So when it now becomes 22, that will throw us and it will come out of the loop. So it is not always a plus plus or a minus minus. There are other methods you can use for the update, which is what you have seen. So this means I'm not taking the step one step at a time. It is 2 steps at a time for me to achieve my goal. So that is another part. So another variation again that I can show to you is I will remove all this and then I will give you this, this. So if I write this loop, I initialize, I declare the variable a, right? But inside this, my for loop, I left this open because it is optional. I left this open because it's also optional. And I left this open because it is also optional. Now, what will this script produce? I can come here and I will write this will run forever. So this is what is going to print out on the screen. And it will print it out continuously. There will be no end to it. So this is eternity, meaning there is no condition. I don't have any goal. So you are working in a company without a goal. When are you going to leave the company? It is eternity. But in reality, something must take you out. Right? But this is an infinite loop that will run forever. So this is another form. You must always have this semicolon. But you might not necessarily have something at the initialization point. You might not have something at the condition point, and you might not have something at the update point. So this will print out, this will run forever. So I'll just put that, this will run forever. This is an infinite loop. Now, what if I have something like this? I have something like this. I create a variable a. Then I say a assign 0. Then I do something like this. A less than 10, right? Then I do this. A minus, minus. Then I do this. Then print f a. Then I do percentage d, and then I do slash n. Then I say a, and I close this. Now, if I have something like this, what do you think will be the output on the screen? Now, will this loop be an infinite loop or a non-infinite loop? Now, my goal is less than 10. This is my goal. I am starting at 0.0, right? But I'm doing negative update. So A is 0. A is less than 10. That is true. It will come in and it will print out A. So it will print out A 0, right, on the screen. Then it will what? Decrease. So A is 0. It will now become -1. A will now become -1. Then when you get here, -1 less than 10. That is true. It will come in and it will print what? A -1. Then it will decrease again. That will become what? -2. But with this loop, because this is never going to be false, I'm never going to meet this goal. So I am setting a goal, but instead of moving towards the goal, I am moving away from the goal. So I am never going to achieve the goal. So will this be an infinite loop? This is a tricky question. It depends on the compiler. Why? Because this is a signed integer, right? And a signed integer can occupy -21, -21474, 83648, right? It can take from this range to 21474, 83647, right? This is the range for a signed integer, from this range to this range. So that is the range of numbers that it can take. Now, if I run this program and I'm going at the negative angle, that is walking away from my goal, eventually I'm going to get to this number. I'm going to get to this. Now, when I get to this, depending on the compiler, there will be an overflow, like a tipping point. It will tip. It will go from this point to this point. Now, as soon as it tips to this point, this is no longer less than 10. It is expected that this loop should end at that point. But how long will you wait for your computer to run for it to get to this? Also, depending on the compiler, it might become undefined, right? It might become undefined. So it's like going from day to night or night to day. Depending on the compiler, it might become undefined. Or like the story of the prodigal son. The father knew that at a point that child will hit the wall and then return back to the family. But depending on the compiler, it might be undefined, meaning we don't know what the child will do when it gets to that endpoint. So the best answer for this is that it is an infinite loop. That is what I want to tell you, looking at this, because this integer is a signed integer. If it is an unsigned integer, it will all be positive, and then you can always tell, right? So this is going to give us an infinite loop because you are walking away from your goal. And then the last variation that I will show you is where you have double. The last variation is I can declare int I, j, right? I can do this, and then I'll say I will initialize I equals to 0, comma, j equals to 10. Then I will have this. So I am bringing in two variables. So I'm using this comma operator to separate them. Then I will have my semicolon. So I will have I less than or equals to 10. Then I will have this. Then, so since I'm having my I as 0, my I will be what? Plus plus, comma. Since my j equals to 10, my j will be what? Minus minus. Then I will have this. I will have this. Then I will print out print f. I will do this. I will say print f a you're using I percentage d, then comma j percentage d, then slash n, comma I j. Then I close my curly bracket. So we can also have something like this. Now, this is another variation. You can see that I have two variables, but the condition is always 1. So we are using I less than or equals to 10. So I is 0, right? And j is 10. I less than or equals to 10. I is 0, that is true. It will go in and it will print out I. So it will print out I is what? I 0, and then j 10, right? It will print it out this way. Then it will increment I to what? To 1. And it will reduce j to 9. Then it will check 1 is less than or equals to 10. That is true. It will come in and it will print out this. It will print out 9. Then it will increment I to 2. So you are having something like this. You are having something like this. This is I. This is j. Now, when I is 0, j is 10. When I is now 1, j is what? 9. When I is 2, j is what? So it will continue like that until I will become 10, right? And j will become 0. Then the loop will stop. So you can also have something of this nature. So these are the variations that I want to show you. You can have as many variations as possible. Like I said, it's like setting a goal. So you can walk towards your goal, or you can walk backward, or you can walk in a place where there is no goal, meaning there is no escape route. So that is what I want to show you in this for loop variation. So let's go to code blocks. Let me just demonstrate what I've shown you on the screen. All right, so this is our code block as our custom. I've written a program. So what I just did here is to combine two programs together, two for loop together, which is this one and then this one. So this is the one that you're incrementing twice, right? And then this is the one that you're having two declared variables, I and j. And then you're assigning 0 to I and 10 to j. And then one is incrementing and the other one is decrementing. So let's run this program and let's see what this one will give us and what this one will give us. All right. So you see, the first one, which is this one, is giving us 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. While this second one is giving us I equals to 0, j equals to 10. I is 1, j is 9, I is 2, j is 8, right? I is 3, j is 7, like that. So when I equals to 10, j equals to 0. That is what this is giving to us. All right, so now let's do the other one that I showed you. I can comment this. Now to comment this one, I can comment this. So I can comment this. So I will just come here and I will say minus minus. Now, what I did on the board was, I can leave it like this. I can do this 10. All right. So if I execute this program, what will it give to me? This is an infinite loop, but eventually it will get to a tipping point. If I allow it to keep running, depending on the compiler, like this GCC compiler, it will take hours. So I'm not ever going to experience the end. So let's just execute it and see what it will be. You see? It's an infinite loop, continuously running. See? You see? It's never going to stop. It is never going to stop. It's just incrementing the minus. Eventually it will get to what I told you is the highest negative integer, then it will tip. See? Continuously running. So I'm just going to end it. Just going to stop. All right. Now the second one again that I told you was this, removing this, and then removing this. So I am not having any condition. Here I can now write this will run forever, right? So let's execute this one and see. There is no condition, no initialization, and then there is no update. It will print out this will run forever. So let's execute. You see, that is it. It is going to be running forever. It's an infinite loop, right? So that is what will happen, to just keep running that way. So that is what I want to show you in this class. So till we see in the next class. Bye-bye.